Hello everyone and welcome. Today, we are going to explore the world of virtualization technologies by comparing virtual machines and Docker containers. Join us as we unravel the key differences and understand which technology might be the best fit for your needs. So, what exactly is a virtual machine? A virtual machine, often abbreviated as VM, is essentially a software-based emulation of a physical computer. It runs an entire operating system and applications within that operating system, just as if it were running on physical hardware. Think of it as a computer inside a computer. Looking at the diagram, at the base layer is the physical hardware. On top of that, we have the hypervisor, which is the software that manages the virtual machines. Each virtual machine has its own guest operating system, and on top of that, the applications run. Now let's explore Docker containers. A Docker container is a lightweight, portable package that contains an application and all of its dependencies. Unlike virtual machines, containers share the host operating system's kernel. This makes them much more lightweight and efficient. Looking at the diagram, at the base layer is the physical hardware, and then the host operating system. The Docker engine runs on top of the host OS, and finally the containers themselves, which contain the applications and their dependencies. Let's take a closer look at the architectural differences between virtual machines and Docker containers. On the left, we have the virtual machine architecture. Notice how each application runs on its own guest operating system, all managed by a hypervisor that sits on top of the host OS and hardware. On the right, we have the Docker container architecture. Here, applications share the host operating system kernel, with the Docker engine managing the containers. This shared approach is what makes containers so efficient. Now let's compare the resource usage of virtual machines and Docker containers. Virtual machines tend to have heavy memory usage because each VM runs its own full operating system. This leads to multiple operating system overheads, slower boot times, and large storage requirements. On the other hand, Docker containers are much more lightweight. They have minimal storage overhead because they share the host operating system kernel. This results in fast startup times and efficient use of memory. Let's dive into some performance metrics. When it comes to startup time, virtual machines typically take minutes to boot up, whereas Docker containers can start in seconds. Memory usage is high for virtual machines due to the overhead of running multiple operating systems. Docker containers, on the other hand, have low memory usage because they share the host OS kernel. Storage overhead is measured in gigabytes for virtual machines, but only in megabytes for Docker containers, reflecting the efficiency of containers. Now let's explore the typical use cases for each technology. Virtual machines are often used for supporting legacy applications, where different operating system requirements exist, and when strong security isolation is needed. They are also commonly used in desktop virtualization. Docker containers are ideal for microservices architectures, continuous integration and continuous deployment pipelines, often abbreviated as CI/CD pipelines, cloud-native applications, and development environments. Let's summarize the key takeaways from our discussion. Virtual machines provide complete isolation with dedicated operating system instances, making them best for legacy systems and environments with strong security requirements. Docker containers are lightweight and fast, sharing the host kernel. They are perfect for modern applications and cloud deployments, offering efficiency and speed. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.